Hello, pre-calculus students. It's me again, Mr. Hale, and I'm here to talk to you about how we can use our graphing calculators to solve systems of equations using matrices. So let's go ahead and get started. First thing we want to look at is we really want to go ahead and write our augmented matrix. Now I know some of you will probably look at this and say, I could just go ahead and punch it in as is. That's probably alright, but you need to be real careful that you don't miss any numbers or any of the silly mistakes that can happen when you do that. Now I'm going to go to my graphing calculator, and if you look above the x to the -1 button, it says in blue, it says matrix. So I'm going to go to the matrix menu, and then I'm going to choose to edit because I want to create a matrix that looks just like this one. And I'm going to choose matrix A. It doesn't matter which one you choose. Now what do you know? I've already got my information entered. Now basically what I have to look at is the matrix is of dimension 2 by 3, 2 rows, 3 columns. And so I have to type that in. And by the way, you can just press the number and then press enter as you go through this. But once you have the full matrix entered, 3, 4, -2, 5, 3, and 4, we'd want to quit to basically get out of the matrix window. Now perhaps kind of strangely we have to go right back to the matrix menu, so we'll go second matrix, but this time we're going to use the reduced row echelon form, RREF. Now we talked about row echelon form previous, where we were solving by hand, but now we're going to let the computer, the calculator, do the work. So if I hit math, if I choose the math option, and I usually press up to get there, but it's option B, RREF. And then it's going to say, okay, so this is saying reduced row echelon form of what? Well, I'm going to choose the matrix we just typed in, and I apparently hit the wrong button, so let's try that again. Second matrix, and we'll choose matrix A, and there it is. I'm going to find the reduced row echelon form of matrix A. It looks just like that. And when I've done this, now I have my solution, and we just have to make sure we understand what this means. When I see it written like this, that means the first row tells me that x is equal to 2, and the second row tells me that y is -2. So there's our solution, 2, -2. All right, when we look at the next problem, we're really going to walk through that exact same process, the only difference in this case being that the dimension of the matrix is different. We have 3 variables. So I'm going to go back to the matrix menu again, and I'm going to go into edit. I don't need matrix A anymore, the original, the previous one, so I'm just going to go ahead and change it to be a 3 by 4 matrix, and I'll just start typing in the numbers. Alright, I've got my 3 by 4 matrix entered. I usually like to take a quick look over it to make sure I haven't had any typos. And if I hit quit, now I can go back to the matrix menu and do the same thing again. However, I'm going to do a little shortcut here and just scroll up and highlight reduced row echelon form of matrix A. And remember that we just changed what matrix A was, and we have a new answer that looks like the one you see there. So again, we have to make sure we understand what this actually means. And so this means that our x value is 1, our y value is 7, and our z value is -9. Okay, now I did take a little bit of a risk perhaps on that one by not actually writing the matrix in the augmented form. But as long as you enter your numbers correctly, that should be just fine. So there's our result. Pretty fast, isn't it? A little faster than doing it by hand for sure. Okay, go ahead and enter this matrix. The first one you see is matrix A. We're going to do this one together. And then enter the second is matrix B. So go back to your graphing calculators, pause the video, and enter those as A and B, and then we'll walk through what we run into here. All right, so welcome back. I've entered my matrices as A and B, and I just want to walk through and show you what's going to happen. When I do the reduced row echelon form of matrix A, and so here we go, reduced row echelon form, matrix A. I get a matrix that looks like that, and we'll talk about what that means in just a moment. If I do the same thing with matrix B, and again I have to go in and choose the correct matrix. And when I choose it, we choose it on the names menu. I don't think I highlighted that before, but there it is. Okay, so let's talk about these two results because they mean different things. And the key is the last row. And if you look at the last row for matrix A, it's all zeros. Okay, talking about this one right there, all zeros. That tells me that what we have here is an infinite solutions situation. Now, we can actually use this to figure it out, exactly like how X, Y, and Z compare to each other. And so what we'll do is we'll have essentially two equations. The first one says X plus 3Z is equal to 10. And then the second equation, and actually let's go ahead and solve that for X. Why not? So X is negative 3Z plus 10. And then we'd have Y minus 5Z equals negative 7. So then Y equals 5Z minus 7. So we've got our answer. In terms of Z, it's negative 3Z plus 10, 5Z minus 7, and then finally just Z. Okay, now for matrix B, we again have to look at the third row. But you have to think about this. This means 0x plus 0y plus 0z equals 1. Folks, what you have going on there is no solution. Now you shouldn't get no solution and you shouldn't get infinite when you're doing the application problems that we're mostly focusing on today. But when you're just solving a system that doesn't have real life application, it's very much possible to get either of these results as we've seen in the past. So let's go ahead and take a look at some of these application problems. The first thing we're going to take a look at is this one here where we have a family attending a soccer game. So the Hundelts go and they spend $23.50 on concessions, and it tells you what they buy. The Prodzinskis, they spend $33. The Okwanes spend $45, and you can see what everyone has purchased. So in order to set up our system on this problem, we really should define variables so we know what stands for what. So I'm going to define X, and I'm going to try to stay in the same order. So X would be, and at the last of the problem it says what is the cost for each of the three items. So this would be the cost for hot dogs, and really when I say hot dogs I should probably say for one hot dog. Y would be the same thing, cost for a Coke. And then the final thing, Z, is the cost for a popcorn. All right, so we're going to consider each of the three families. Let's start with the Hundelts. They purchased 2 hot dogs, that's 2X, 3 Cokes, and 1 popcorn, and spent $23.50. The Pronzitskis get 4 hot dogs, 2 Cokes, and 2 popcorns, and they spend $33. And then finally the Okwanes gets, let's see, 1 hot dog, 6 Cokes, and 4 popcorns, and spend $45. Now folks, we could have solved this system by hand, but I think you guys have the idea now that, hey, if we can solve it on the calculator, why not use this reduced row echelon form thing? So go ahead and do that. Take a moment, pause the video again, solve the system to find the cost of each of the 3 items. All right, welcome back. I've entered this matrix. I've gone ahead and done the reduced row echelon form. And basically what I found out was that hot dogs were $4. The Coke was $3.50, and popcorn looks like $5 for a bag of popcorn. All right, I don't know about you, but these matrices things seem pretty cool. I like them a lot. All right, this last one we're going to look at, there's a little bit of a challenge in the setup, so I want to make sure we kind of walk through this one together. So Joy's eating her favorite meal, steak, baked potatoes, and green beans. 1 serving of steak has the given information for calories, carbohydrates, and sodium. A baked potato, you guys can read that info, and then green beans. For the meal, Joy consumed a total of 680 calories, 15 grams of carbohydrates, and 875 milligrams of sodium. How many servings of each food did Joy eat? So what we need to do is, that last sentence is key. How many servings of each food? So that tells me about the variables, okay? So I'm going to say X would be the servings of steak, Y would be the baked potato, and Z would be green beans. The order here isn't really important, but what does matter is that you make sure you keep it organized. Now, the challenge that people sometimes run into on this is, how do I set up the equations on this thing? Because we don't have a steak equation or a potato or a green beans equation. What we do is we have equations based on the different attributes of the meal. So calories, carbohydrates, and sodium. So if we were to do our calories equation, it would say, okay, so one serving of steak would be 250 calories. One serving of the baked potato would be 200 calories. And then one serving of green beans would have 80 calories. And it says here that Joy's meal was a grand total of 680. Now we're going to repeat that with carbohydrates. So for the carbohydrates, it's 0x, so you can just leave that one out if you want. Then on to the baked potato, that's 22. And then the green beans would be 4. And she consumed a grand total of 15 carbs. And then finally, for the sodium, we had the steak had 300. The baked potato had 150. The green beans, 200. And her grand total for the meal was 875. Folks, right here you've got your system. If you'll change that to a matrix, you can solve and figure out what Joy had for her meal. So again, pause the video and do the calculator work here. All right, I've done the calculator work here. You can see what I've got. So it looks like for how many servings of each food did Joy eat? We would say Joy ate 2 steaks. That sounds good. Nice choice. She ate 1/2 a potato and 1 serving of green beans. Sounds like a pretty tasty meal. Also, seems like you got a pretty good lesson there. So folks, you now have the knowledge you need to be able to answer the questions today. You will run into some situations that are slightly different, but you're all in this class because you're bright and intelligent and you are good problem solvers. So I appreciate you paying attention and taking good notes. You all have a spectacular day.